Now that we have finished our structural model in Revit, we need to review the analytical model before exporting it to ETABS. We need to make sure all structural elements are associated with analytical model and all the constraints are set up properly. To review the analytical model, open a 3D view and from Visibility Graphic Settings, hide all the model categories and unhide analytical model categories. When looking at analytical model, search for all the structural elements. Columns and beams should be presented as analytical columns and analytical beams. Structural floors and structural walls also should be shown as analytical surfaces. If you are missing an analytical model, go back to structural model. Search for the element that is missing its analytical model and make sure the option Enable Analytical Model is selected. After reviewing the analytical model, we need to set up our constraints. Typically in concrete structure like this, we only need to make sure that the bottom connection of all columns are fixed and all other joints are released. Select all the analytical columns using Filter. And then look for the top and bottom constraints in Properties. Make sure the base is fixed and the top connection is released. Click on Apply and then select all the analytical beams. In this case, both the start and end connection for all the beams should be released. Also, you may need to check the alignment of analytical elements. For example, the slab edges around the opening should be aligned with analytical walls. To review that, open a floor plan and see if the opening edge is right on top of the analytical walls. In this case, our opening is aligned with the outer face of the wall, which is correct in the real world. However, the structural software may require the slab edges to be aligned with the center line of the walls. To fix this problem, you can select an analytical model, click on Analytical Adjust, and then try to move the floor edges to the center line of the walls. This process may take quite a long time because you need to do this for all the floors and all the walls in the entire model. Since we are using CSI Link application to export the analytical model, we can take advantage of CSI Link application to automatically adjust the analytical model. We will come back to this point when we're talking about the CSI Link options. Now that we have completed our review of analytical model, we need to make sure that material assigned to structural elements are as per design criteria. To review the material setting, select a structural model, for example a column, and then under Material and Finishes, see if any material is assigned to a structural element. Here we have concrete casting place gray assigned to a structural element. Open the material settings. Make sure that the physical asset has been assigned to the material. Here you can find the structural property of the concrete, such as concrete compression, shear strength modification, etc. All these settings will be exported to CSI ETABS. Therefore, you need to make sure all these settings are as per standards which you are following. Also make sure that all the other elements, such as beams and slabs, are using the same material. After finishing the material setting, now it's time to open the CSI Link add-in. If the CSI Link add-in is installed properly, you should be able to see the CSI Link tab in Revit interface. The first thing we need to do is to open the setting dialog. If you're doing this for the first time, it may take few seconds. After the settings dialog is open, we need to define the target file name and the destination folder in order to export the Revit model to CSI ETABS. First, choose a folder. Second, enter a name. Notice every time that you export to ETABS, the application will override the file without prior notification. So if the file is already exists, you may need to back up your file in case you need to have the older version. Now we move to the second tab, the elements. In this section, you can select the elements which you like to export to ETABS. CSI Link can export the grids, the structural columns, the structural beams, slabs, walls, loads and load combinations, links, and it can also generate the design strips. For this tutorial, we don't have any links, so we can uncheck the links option. Also, we don't have any curve wall, so we can leave that. Also, we don't have any curve wall, so we don't need any subdivision. Notice that you can also export loads and load combination. However, we have not created any loads in the model. We'll generate loads automatically using CSI Link floor loads in the next steps. Now open the next tab, the level. In this section, we need to choose the levels which we wish to export them to ETABS. Generally, in a Revit model, there might be many levels, but not all of them corresponds to a story. In this table, we need to select the levels that corresponds to building a story. In our example, in every level, we have a structural slab. Therefore, we need to select all the levels in the model. You can also use check only levels with associated floor plans. This will select only the levels that are associated with the floor plans. Next is section mapping. CSI Link application uses this table to translate the cross sections from Revit to CSI ETABS or CSI Safe. On the left side of the table, you get the list of families that exist in the file. On the top of the table, you get the list of parameters that defines the section properties. You can hover above the column header to see the short description of the parameter. Usually, CSI Link application will set the parameter automatically. However, you need to review the settings and make sure all the parameters are assigned correctly. In our example, we are using two types of sections. A rectangular section for the beam and a rectangular section for the column. So we need to check that the concrete rectangular column and concrete rectangular beams are assigned to correct sections and the parameters are assigned correctly. Under the section, make sure the rectangular is selected for both cross sections. Also make sure the parameter H and B are selected correctly for the rectangular section. We don't have to worry about the other parameters because we are not using these families in our model. Next tab is default materials. In this section, you can alter the settings of default materials. If you haven't assigned a structural material to structural elements, then CSI Link application will use these default settings to export the material properties. In this tutorial, we already assigned a structural material to all the columns, beams, and slabs. Since the structural material is already assigned, those settings will be used, and default materials will be ignored. Now we move to general settings. The detailed explanation of all options in this section can be found in CSI Link documentation. However, for this tutorial, we are going to look at auto adjust model settings and CSI ETABS export settings. In ETABS export settings, we have two options of split columns and split beams. You may notice that we model the structural beams and columns as a single column rising from level 0 all the way to the level 6, and 4 single beams that are aligned with the slab edges. Normally, when we do a structure analysis, we should divide the columns per level and beams in between the columns. This subdivision can be done during the export using CSI Link export settings. So make sure that both options are selected. Auto adjust model settings will help us to align analytical elements. For example, align the slab edges to the wall will help us to align the opening edges to the center line of the walls. Check align slab edges to the wall and make sure the threshold is set to 1 foot. Hit OK button. Now if you remember, we have modeled our opening in such a way that the slab edges were aligned with outer face of the wall. In a proper analytical model, these edges should be aligned with the center line of the wall, where the analytical lines are located for the walls. Using auto align slab edges to the wall options in CSI Link will do this automatically during the export process. Now open the slab settings. In this dialog, we can alter the structural settings of the slabs. Open the drop-down menu. You will find all the structural slabs that are used in this model. For 8-inch concrete slab, under the slab type, choose a slab. Under the modeling type, choose shell thin. And under the diaphragm, choose rigid. Press apply. Now select the 15-inch drop. From the slab type, choose drop. From modeling type, choose shell thin. Also choose rigid for diaphragm settings. When you choose a diaphragm, it will automatically assign a diaphragm to all the slabs of this type. Now hit OK. Notice these settings will be saved in family types. So if you're making a new slab of that type, you don't have to actually adjust the settings again. Also, all the settings of CSI Link will be saved in the Revit file, and you don't need to set them again. Now click on wall settings. We see only we have one type of walls used in the model. Under the ETABS modeling type, choose shell thin. Hit OK. Open the column settings. We're using only 24 by 24 inch concrete columns. Settings in this section is related to CSI Safe, so we don't need to do any further adjustments. Hit cancel. Now we need to create our floor loads. Before that, we need to make sure we have the load types available in the model. Go under Analysis and select Loads. Choose an area load and make an area load anywhere in the model. So now we have one type of area load. Rename the type, call it dead load. Duplicate dead load type and create a live load as well. Now we have two types of load in our model. Delete the area load that you just created. Now open a 3D view and go ahead, click on floor loads. Using this table, we can generate area load per floor types. From the floor type column, choose 8-inch concrete slab. From the load type, choose dead load. From the load case, choose DL1, which corresponds to dead load. For more information about the load cases in Revit, you can see the Analyze tab. Now enter a negative number representing the amount of load. Notice that I'm entering the load in kips per square feet. Also, the negative means the load will be in gravity direction. In the next row, we will assign a live load on the same slab. Again, from the floor type, choose 8-inch concrete. Choose live load for the load type. And then from the load case, choose LL1, which corresponds to the live load case. Enter the amount of live load. Now, click on Generate Loads. This message tells you how many loads are created and how many of them are updated. Close the dialog. Click on Save and Close. You can already see the area loads that are created using the floor loads options in CSI Link. This is our live load. This is our dead load. And it has been assigned to all the slabs. Now we are ready to export the file. Click on Export ETABS. A dialog will show you the process of the export. Once the export process is completed, if there is any warning, you can see the details by clicking on Yes, show me the details. In this report, we only have one warning, which is related to the column settings. These settings can be ignored because it's related to CSI Safe application. Now we open the file in ETABS. Use Import E2K text file. You can see all the elements are imported without any error. Also, you can see that beams are now divided to smaller beams that run from column to column. And also columns are divided to the small columns that are going from the floor to floor. Also, you can see that our opening edges is exactly running above the center line of the walls. From Analyze menu, run a check. You should see that model has been checked and no warning message were generated. This means this model is clean and is ready for analysis. Also, you can check for the loads that are assigned to each slab. The dead and live load are assigned as per the settings in Revit. Now go ahead and run analysis. Now let us see the result of analysis and compare that result with another model which is made in ETABS. For example, in level 6, show the shell forces for the load case DL1 and choose the component M11. Here you can see the distribution of the moment. Now let us compare that result with the original model. As you can see, there are no differences in the result. Using CSI Link application in Revit, you can also export Revit to CSI Safe. You can follow the same procedure. However, instead of using export ETABS command, you simply click on Export Save command. I hope this video helps you to understand CSI Link commands and makes this application part of your workflow. Thanks for watching.